Hello again, folks. We continue with another lecture on trigonometry. So we have an angle in standard position here, and this angle has a terminal arm which is located in the third quadrant. In the third quadrant, we have a point on the terminal arm, and that is point P, okay? And the measure of the angle in standard position is given to be 5 pi over 4. 5 pi over 4 would be 225 degrees if you convert it into degrees. Now, if this whole angle is 225 degrees, and we know that a straight angle is 180 degrees, so the difference would be 45 degrees from 180 up to 225. So that means that the reference angle alpha is pi over 4 radian, which is 45 degrees. So basically, this triangle here that can be generated, it's a right angle triangle, has an angle of 45 degrees. So I can redraw it here, okay? So this is 45 degrees right there, and this one is also 45, and it's an isosceles triangle. So that point P, which is like any point on the terminal arm, could possibly have an x and y coordinates of -1 and -1, because according to the special triangles, we know that if you have a 45, 45, 90 degree triangle, if the two sides are 1 and 1, then the hypotenuse is √2, and the angle is 45 degrees. So here we have 45 degree angle. So that means that this could be 1 unit, this could be 1 unit, this could be √2 units, just using the standards that we have before. But the thing is that here, the x and y coordinates are negative because the terminal arm lies in the third quadrant. So how can we calculate cosine of 5 pi over 4? Well, we're going to say cosine is defined as x over r, obviously. So that's x over r. And r here is square root of 2, right? And the answer would be -1, because x is -1, over square root of 2. And that is the answer for cosine of 5 pi over 4, which is cosine of 225 degrees. I'm going to use the calculator and find cosine of 5 pi over 4. 5 times pi over 4. Mind you, you have to put your calculator in the radian mode if you're punching in an angle in radian, obviously. And if you're punching an angle in degrees, it has to be in the degree mode, logically speaking. So right now, I got -√2 over 2, which is exactly the same answer we got if you rationalize the denominator. So -√2 over 2, matching with the result obtained from the calculator. So this is how you find cosine of 5 pi over 4. If they say find sine of 5 pi over 4, instead of x over r, you're going to use y over r, okay? And you're going to plug in y coordinate, which is -1. So we know that x is -1 and y is -1, okay? And if you want to find r, as I said, Pythagorean theorem. If they say what is tangent of 5 pi over 4, you're going to use this formula, y over x. So it's going to be -1 over -1. The answer is +1, of course. In this other example, it says tangent of some angle in standard position, which they call it angle theta, is -1 over 3. This angle is between 0 and 2 pi inclusive, okay? So basically, it is an angle in one of the 4 quadrants. The terminal arm lies in one of the 4 quadrants. And they say find the measure of angle theta. So again, the only thing you do, you always use the formulas, right? Tan of theta is y over x. So if it's y over x, that means that -1 over 3 is equal to y over x. And if that is the case, either the top, y could be -1, and then the bottom could be +3, okay? So y could be -1, x could be 3. Or the other way, maybe the y is positive in the numerator, and the x is negative in the denominator, that is -3. So when you have a negative fraction, -1 over 3 is the same as +1 over -3. So that's why it's hard to tell which one is the case here. Therefore, we're going to create 2 cases. We're going to say, okay, this is case 1, that's one possibility, and this is case 2, that's another possibility, right? Okay, so if it is the first possibility, x is 3, y is -1, so x is 3 on the right side, y is -1, we have an angle in standard position, which is in the 4th quadrant. The terminal arm is in the 4th quadrant. And if you want to find you want to find the measure of the angle, one thing you can do is to use the reference angle. And now you see the importance of the reference angle. Do you see this little right angle triangle here? If I draw it a little bit larger, this is the right angle triangle right there. The opposite side to this reference angle or related acute angle alpha is 1, and the adjacent side is 3 units. Okay, so we can use SOHCAHTOA. Of course, here it's not special angle, but we can use SOHCAHTOA and find tangent of angle alpha, which is opposite over adjacent. Now, to find the measure of angle alpha itself, I can use the inverse tan of 1/3, and I can use the calculator, making sure that my calculator is in the correct mode. If I put it in radian mode, the answer would be in radian. And if it's in the degree mode, the answer would be an angle in degrees, obviously. So right now, my calculator is in the radian mode. So when I'm punching in inverse tan by pressing the shift button or the yellow button or the second function key or the inverse button on my calculator, depending on what model of calculator you're using, if I press inverse tan of 1/3, I get 0.3217. Okay, so I get this as 0.32175, and the answer is in radian. Okay, so the measure of the reference angle is 0.32175 radian. Okay, now you want to convert this into degree multiplied by 180 over pi. Okay, now, but we want to find the measure of angle theta, which is like a huge angle. You know, it's a little bit less than 360 degrees basically. So we're going to say, okay, theta is equal to 1 full revolution take away the measure of alpha. So it's basically 2 pi all the way 1 full revolution, and then you have to go back a little bit by the amount of alpha. So 2 pi minus alpha, which is 2 pi minus 0.32175. So if I use the calculator and I go 2 pi, okay, minus the number 0.32175, I get an answer 5.96. Of course, roughly, okay, 5.96. So that means that the angle in standard position was 5.96 radian. So this is a huge angle because every radian is about 57 degrees, right? So if I multiply this by 180, dividing it by pi, believe it or not, I'm getting 341.5 degrees. So it makes sense that this angle is huge and it's 341.5 degrees, which is like a little less than 360 degrees, right? So this is one possibility. The question says tangent of theta is -1/3. Find the measure of angle theta. We did find it. It is 5.96 radian, roughly 341.5 degrees. But this was one possibility if we assume that the terminal arm lies in the fourth quadrant and x is 3 and y is -1. But what if it's the other way? What if x is -3 and y is +1? In that case, when you draw the angle in standard position, you end up with a terminal arm in the second quadrant this time. So if that is the case, so again, the reference angle here would be alpha. And if you construct a right angle triangle, it's going to look like something like this, okay? So right now, this is alpha, the reference angle, related acute angle. Opposite is 3, adjacent is 3. Opposite is 1, adjacent is 3. And inverse tan of 1/3 would give you the same answer I got here. So we know that alpha is 0.32175 in radian, of course. That's the measure of the related acute angle. But we are looking for angle theta, which is an obtuse angle. So theta, when you look at it, it is going to be pi, which is the straight angle, 180 degrees, and then take away alpha, because theta is pi minus alpha, basically. So pi minus alpha. So if you subtract 0.32175 from pi, which is 3.14, roughly. So let me do it. So I punch in pi minus 0.32175. You get the answer 2.82. So 2.82 radian. So the answer to this angle is 2.82 radian. We know that it's an obtuse angle. Let me check to see if it is. So I'm going to multiply by 180 divided by pi, converting it to degrees. I got 161.5 degrees right there. So the measure of the angle is 161.5 degrees, which is matching with the fact that this angle is supposed to be an obtuse angle in the second quadrant. So everything should make sense. Everything should match with one another. So the question says find theta. The answer is theta sub 1. One solution, one possible answer is 5.96. Okay. And the other solution, theta sub 2, is 2.82, of course, radian, and that is in the second quadrant. So when tangent of an angle is a negative number, it's either in the second quadrant where tangent is negative, or it is in the fourth quadrant where tangent is negative. You see, minus here, minus there. And this is in accordance with what we said. In the second quadrant, tangent is negative, or in the fourth quadrant, tangent is negative. So there's two possibilities out there. One is 5.96 radian. The other one is 2.82 radian. Okay. Now, instead of negative 1/3, they give you whatever number. You're going to do the same thing, the same way you solve the problem. If instead of, for example, tangent, they give you sine or cosine, you are going to find the r value, which in this case, r is actually 1 squared plus negative 3 squared. So that's going to be 10. So that's a square root of 10. You're going to find the value of r, and then you're going to use it in the sine and cosine ratios easily. Okay. Here I didn't use it because my formula was y over x for tangent of theta. I didn't need to use r. I didn't even bother calculating it. But if you're finding an angle whose sine is negative 1/3 or whose cosine is negative 1/3, and you need to find r, well, Pythagorean theorem is always valid. The formula is always there for you to use. Okay, now you just have to practice as much as you can. Thank you very much.